applications of systems of linear equations. So far you've been given a system of equations and developed your skills in solving them. Sometimes you will be given a problem to solve where you have to come up with the equations, right? So mostly we've given you equations that, here, solve by substitution, here, solve by elimination. But when given an application problem, you must solve the problem using 4 steps. Label the unknown values with appropriate variables and be specific. So ways that you can do that are with let statements. So you can have a couple of statements at the very top of the question saying, let x be this. Let y be that. You can have a diagram upon which you label the length and the width, let's say. So you're doing an area problem, so you say, L and W. You can come up with a table where you put stuff, right? And we've done that. Table with distance, speed, time, especially. So somehow you label the unknown values with appropriate variables being specific. You read the problem carefully and translate the information into a system of equations. Okay? So generally the last sentence is going to say this is what you want to find, and that becomes your unknown, right? Or your x, or depending on the context, you may put in appropriate variables. Solve the system algebraically, so substitution or elimination, and write a sentence solution and verify your solution, right? So then state your solution, and then, so we're just going to do a few examples of that. Determine the value of x and y. Okay. So in this case, we have a diagram. Our variables are on there. Okay, so we don't have to label the unknown variables. We don't really have to read the problem and translate the information into a system. How are we going to solve this? What do we know about 3y minus x and 5x plus y?
They're the same.
They're the same. Right? Usually the answer to 90% of the things we do, right? They're the same. In this case, they're the same. So 3y minus x is equal to 5x plus y. So is that going to solve things? No. Right, because all we'll end up with is 2 unknowns still, right? I mean, we can get it down to something y equals something else. Yes? Sorry, 3x plus what? What?
I mean, sorry, 5x plus y plus 100.
Yeah, okay, so what's 5x plus y equal to? Really? What's 3y minus x equal to? 80. What's 5x plus y equal to? Okay. How do we know? Well, we know they're equal to each other, and they make a straight angle with 100 degrees, and a straight angle has a measure of 180, so we know they're both equal to. So what are we going to do? 1, 2. Okay, so what are we going to do? Solve. Solve what for what? Solve 1 for x. Okay, solve 1 for x. So 3y minus x equals 80. What's x equal to? 3y minus 80. Okay, now what? Substitute. So what method are we using to solve? Substitution. So we're going to substitute 3y minus 80 for x in 2, right? We've already used 1, so we can't use 1 again. Okay, so what's 2? 2 is 5x plus y equals 80. So this is 5 times 3y minus 80 plus y equals 80. So now we have an equation just in one variable, right? That's the whole idea of substitution. We substituted for the x, we have an equation simply in y. We're going to solve this. So what do we got? 15y minus 400 plus 16y is equal to, so y is equal to 30. And what's x? How are we going to solve for x?
Substitute
First equation? Where are we? 3y minus x equals 80. Three times 30. And what do we get? Yes. No worries. Okay.
X equals 10, y equals 30.
Okay. So now what? Okay, so we might want to go back up here. Now, I'm not even looking at this now, right? I'm just going up here and I'm saying, okay, what do we say? X is 10, so this is 50 plus, 50 plus 30, which is 80, and this is 90 minus 10, which is 80. So they're 80 and 80, which are equal to each other, and they're the supplementary angle with the 100, so it's all good, right? So we've checked it, and now we write, so the value of x is 10, and the value of y is 30. Right? So, nice solution, right? We didn't have to do anything because we were given a diagram that had the variables, but then we had to get a system of equations, right? So we started out by setting them equal to each other, but that didn't really go anywhere, right? Okay, they're equal to each other. It doesn't help me solve this. Okay, so what else do I know? Well, they're both equal to 80. 5 burgers and 3 shakes cost $25.50, but I think I should really say while 3 burgers and 2 shakes cost $15.75. Determine the price of 4 burgers and 1 shake. Okay, what do we have to find?
X and Y.
X and Y. What's what? Oh,
Oh, X is burgers and Y is shakes.
okay. Why not let B be burgers and S be shakes? Or if you have a perverse sense of humor, let S be burgers and B be shakes. But I advise against that. There's nothing strictly wrong with it. You're just likely to see a big X somewhere until the end, but you know. Okay, so here's how I mark this, right? First thing, I'm gonna look at the final sentence, right? That says the price of 4 burgers. So we really have to work out the price of 1 burger, right? Then we're just gonna quadruple it and 1 shake, right? So I'm gonna look at the final sentence, which is gonna say the price of 4 burgers and 1, and 1 term. I guess you could do it as one thing, right? The price of 4 burgers and 1 shake is, and just give me one number. So I'm gonna look at that. If that's correct, then I'm gonna figure, okay, you probably did this correctly. And then I'm gonna look back at the work to see, is there an algebraic justification, right? Because really, there's only a finite number of numbers that a burger and a shake could be, so you could just figure it out. Just say, I think it's like let's try $2 and $3.50, right? And eventually come up with something that works. But that's not what we're going to do, right? So we're going to start with a statement, right? Let B be the price of 1 burger. And S be the price of a shake. Okay, so we've defined our variables. What's next? Need equations. What's our first equation? 5b plus 3s equals 25.50. Okay, and what else?
3b plus 2s equals 6.
Right? Okay, so we're taking the information that was given, which is the price of number. This is a very common type of question, right? You know, with burgers and shakes, with like footballs and soccer balls, student tickets and adult tickets, basically anything that, kind of, usually it's in the situation of a price. Okay, but be aware, that's what we've got, right? We're supposed to find the price of, not the number of, right? How many of these things, but the price of. Okay. So, this is 1. This is 2. How would you like to solve this? Elimination. What would you like to eliminate?
One. Yes. Yes.
We want to eliminate s. Okay, so what are we going to do to equation 1?
Multiply by two.
Okay, so 2 times 1. 10b plus 6s equals 2550.
What? No. No.
Ah,
I knew you were gonna do that.
good. I did too. And what should it be?
51.
51. Right? So make sure you're multiplying everything, right? Every term that's up there. And what are we going to do to equation 2? 3 times 2. So the idea is we want to get, now we could also go -3, right? So your choice. If we do 3, we're going to subtract. That's okay because this will be a 9, so subtracting is not a big deal, right? If this were going to end up being greater, then maybe I multiply by negative and I can add, but your choice. Okay, you can multiply by 3, -3, doesn't matter. 9b plus 6s is equal to, what, 47 and a quarter? How much?
47.25.
Yeah, I did that in my head, 47.2. Okay, now what are we going to do? Okay, we're going to subtract. Right, what does that give us, right? These are all lines, right? They're all just lines. We're solving linear equations, so they're all just lines. They intersect in one point. We're getting new equations. Those new equations have what in common with each other? They all pass through the same point, right? So no matter what I do, when I multiply, well, multiplying really just gives me the same line, right? You know that from last, according to geometry. But adding or subtracting gives me a different line. In this case, it'll be a vertical line or horizontal line, depending on which axis you make the b axis and which one you make the s axis, right? All right, anyways, what do we get? B is equal to
375.
375. That's solved nicely, right? Okay, now what do we do?
Find the shape.
Find the shake. So what are we going to substitute into?
First.
First one? Does it matter? Not really. Okay, 5 times 375 plus 3s. So what do we get? We got 15, and then 375 or something. Was it 1875? What is it? 1875. So 3s is equal to whatever that minus that is. 6.75. And so s is 2.25. So what are we going to say? I'm actually going to throw that number in there, right? So what is it? It's 12 plus this $15, right? And what was it? 4 burgers and 1 shake? And what do we get? 17 and a quarter? Okay. Yes? No? Questions? Yeah.
Question.
Yes.
Okay, so let's say you solve for burgers as 375.
Mhm.
You just simply multiply by 4 and then we solve for shapes. Would you accept it everywhere or something?
No. When you solve for burgers, you then go back to the original and you solve for shake. Okay? We're not solving for 4b. We're solving for b, but we're giving the price of 4b. So then what you want to do is also do a check back or a back check, right? So burgers are 375 and shakes are 2 and a quarter. So you want to go back to here, not here, right? What if you made a mistake doing this, right? So I want to go 5 burgers and 3 shakes, right? 5 times 375 plus 3 times 2.25. You know? And then 3 burgers and 2 shakes. So 3 times whatever plus 2 times whatever, right? And I want to see if those work out. So when I solve word problems, I go back to the original words. I don't go back to this, because if I made a mistake in setting one of these up, then I have not solved the correct system. And if I check back in here, I'm simply checking that I have the correct solution to the wrong system. All right, I'm going to assume that it checks. Okay, what's next? Sam invested $8,000, part at 5% and the remainder at 4%. And the question would be, why? Why not all at 5%? I mean, really.
That's what I was wondering.
After 1 year, Sam earned $175 more on the 5% investment than he did on the 4% investment. Determine how much Sam invested at each rate. Okay, so an answer to the why might be maybe there was a limit on the amount of money you could put into the 5%, right? And we're going to assume that, because otherwise Sam's an idiot, right? Or they were for differing times, so that he put in, you know, that's known as laddering your investments, right? I mean, you just, if you renew, have a set of rolling investments that renew each year, you know, you can get a laddered rate of interest. So you'll take into account fluctuations in interest rates, which, mind you, in your lifetime haven't been very much, right? Interest rates haven't changed a whole lot. Well, maybe when you were like really young, but you know, back in the old days, in olden times, when there were interest rates were like 20% on mortgages. So you know, your parents would remember that probably. Anyways,
Big numbers, big.
so we need to figure out how much was invested at each amount and how much interest was earned. So, guys, can you not do that? Seriously, go out in the hall, have your conversations, come back when you're all talked out. It'll probably be about 3 months, but that's fine. I don't mind. You don't want to be in here, don't be in here, right? You have 2 choices, right? You got it in here, you can pay attention, you understand, you can do it, or you can go out in the hall and talk. What this type of question lends itself to is doing a table to get the information organized, right? So here's how we're going to set up the table. We are going to say that we have an amount invested, and we're going to have interest earned. And we've got that for 2 scenarios, right? We've got the 5% and we've got the 4%. So the amount invested, we don't know, right? So we're going to say X and Y. So we'll let X be the amount, and we're going to say this in the chart, right? You don't have to. You could do this with a let statement, saying let X be the amount invested at 5%, let Y be the amount invested at 4%. Okay? And there's a relationship between those two, right, which we know. And what else? So the interest earned, how much interest will you earn? Well, you'll earn 5% of X, and 5% of X is 0.05X, and you'll earn 4% of Y, which is 0.04Y. No, sorry, I realize it's been the weekend since you've seen each other, and that's why you had to do your catching up. But, you know, unless you're commiserating about the Stampeders' loss,
That was funny.
not even playing the game. You know, if you're going to make it to the Grey Cup, you should at least play in it. Well, there's a little of that, but you can't blame it all on that, right? Like, they just came out flat. Okay, so we're going to set up some equations. What do we know about X and Y?
There.
Yeah, their money, and their sum total is $8,000. Now we know that Sam earned more interest on the 5% than he did on the 4%, so how are we going to express this second sentence? After 1 year, Sam earned $175 more on the 5%. 0.05x. Yep. Minus 0.04y equals 175. You have many variations on this, right? You could go 175 equals, you could reverse it. You could go 0.05x minus 175 equals 0.04y, because it was more. You could go 0.04y plus 175 equals, but generally speaking, in a system, we like to keep our x's and y's on one side and numbers on the other side, and this is the way to do that. Okay, how do you want to solve? Which method?
Substitution.
Substitution, right? Now we could do elimination, just multiply through by 0.05x, right? That'll give me 0.01y equals something. That would be fairly efficient to do that. Right? We can also solve by substitution. I think elimination is probably actually a little more efficient, this one. Yeah. Well, let me show you. So, I mean, you know what you would do for substitution, right? Let's try it with elimination. Because elimination, do I have to multiply both equations? No. Okay, let's put it this way. Anytime you have a substitution situation that you choose to solve by elimination, you only have to multiply one of the equations, right? So, you know, now on the test, we will specifically say, solve this by substitution, solve this by elimination. All right, let's go 0.05 times 1, which will give me 0.05x plus 0.05y is equal to 5% of 8,400. And then we're just going to use equation 2, 0.05x minus 0.04y equals 175. Subtract, what do we get? 0.09y equals 225. We're subtracting. Made the x's the same, but not opposite signs, so we subtract. And what's y equal to? Well, 225 divided by 9 is 15, right?
25.
Really? Okay. Yeah, 2,500?
Yeah.
Okay. So, what's x equal to? Now, if you want to show it, you do that. So, x plus 25. X equals 55. 100. So before we state that in a statement, let's go back and check. We're ignoring everything we've done, right? Other than the fact that the amount at 5%. Okay, so part of 5% after 1 year. Say I'm at 100. So 5% of, what was the amount? 5,500. What's 5% of 5,500? Sorry? 275. And 4% of 20, what was it, 2,500? 100. And 275 minus 100? Okay, so numbers work, right? It checks, so what do we need? Statement, the amount invested at 5% is $5,500. While, maybe and, I don't know. And the amount invested at 4% is $2,500. Okay? So we checked back, right, to make sure that those were in fact the correct numbers, then we're writing our statement. So, yeah, here it is. Any questions? Oh my God, there's so many more. A 60% sulfuric acid solution will be mixed with a 90% sulfuric acid solution. Determine how much of each type of solution is required to produce 2,700 milliliters of a 70% solution. Okay? So what will our solution, if you're mixing 60 and 90 together, what's the lowest concentration you can get? 60. And what's the highest you can get? 90. So if I mix them like 2 parts to 1, I'm going to get halfway in between, right? Depending on which one I mix 2 parts of. Or sorry, if I mix them 1 to 1, we're going to end up with what? 60, 90, 75%. Okay? But we want to get a 70% solution. This is called a mixture problem. Okay? And there's a lot of different mixture problems. So it could be with liquids. It could be with mixing peanuts and cashews to make a nut mix, right? The peanuts cost so much and cashews cost so much. You want to make so much. Okay, usually, again, this lends us to making a table. Okay? So in our table, we're going to say we have 60% solution, we have 90% solution, and we have 70% solution. And we've got the amount of solution and the amount of acid. Okay, so in a 60% solution, 60%, we have 1 liter of that, 60% of it, or 600 mils, will be acid, and 400 mils will be not. It'll be water, likely, right? In a 90% solution, if we have a liter, 90% of it is acid, 900 mils of acid, and 100 mils of water. So the amount of solution, we don't know. So we're saying X and Y, but how much are we going to end up with of the 70%? 2,700 milliliters, right? So we do know how much we want to end up with there. The amount of acid, okay, we have 60% of the solution is acid. That's 0.6x. For the 90% solution, how much of it is acid? 0.9y. For the 70% solution, how much of it is acid? 0.7 times, which is how much? 18. What? 90. 1890. Gotta speak up, I'm old. Yeah. Huh? Real old. How old do you make me feel? Okay. So what are our 2 equations going to be? And? Okay, we do the exact same thing as the last one, so this time instead let's solve it by elimination. No, that wasn't elimination. Let's solve by substitution. Okay, what do you want to solve for, X or Y?
Y.
Y. You sure?
Yes.
All right. Okay, you can use either method. It really doesn't matter. It's not going to make a horrendous amount of difference, right? Okay, so we're going to solve 1 for Y. Leading to Y equals 2,700 minus X. We are then going to substitute. $2,700 minus X for Y in equation 2, giving us what? 0.6, well, let's just write it out first. 0.9y equals 1890. Okay, now let's do the substitution. So 0.6x plus 0.9 times 2700 minus x is equal to 1890. What's 0.9 times 2700? 2430? 24 minus 0.9x equals. See, that's why I would have solved for x, not like we're solving for y. You got all these negatives, but it's no big deal, right? It's just negative this. So negative 0.3x is equal to negative what? Negative 540? So what's x equal to? 1800. So what's y equal to? Okay, at this point, really, you can just write out what y is. It's kind of obvious. They add up to 2700. It's not like you really need to show a lot of work to get to y value. Okay, so yeah, I'm willing to. Okay, before we make the statement, we should go check this. I'm not looking at anything, right? I'm just saying x is 1800, which is the 60% is 1800. So if the 60% is 1800, the 60% of 1800 is how much? 60% of 1800. What? 540? And what's 90% of 900? 810, right? What's 540 and 810? 1350. Okay, what's 70% of 2700? What's 70% of 2700? 1890. Okay, wait a sec. What was x? X is 1800. Okay, yeah, so that's right, 1890, right? Okay, wait, so 0.6x is how much? No, 0.6 of 1800. How much? 980. You didn't need to say it was 540? You're trying to confuse me? Alright, 19. So 60% of 1800 is 1080. Well, you were halfway there. Okay? And 810. And 810 and 1080 is 1890. And 70% of 2700 is 1890. Right? So yes, it all works out. No thanks to you. Okay, so what's our final statement, right? You need 1800 milliliters of the 60% solution. And 900 milliliters of the 90% solution. Okay, questions? That's a mixture problem, right? You're going to see lots of mixture problems. A riverboat took 2 hours. You already did one like this, right? You've done ones like this. Haven't you? Have you? Yeah. Okay. Riverboat took 2 hours to travel 24 kilometers down a river with a current and 3 hours to make the return trip against the current. Determine the speed of the boat in still water and the speed of the current. Okay, distance, speed, time problem. So you do a distance, speed, time table. Time, distance, speed, time. What do we got? We got with current, against current. Riverboat took 2 hours to travel 24 kilometers down a river with the current. So what are we going to put for our speed? X plus y. And 3 hours to make the return trip. And what are we going to put for the speed? x minus y. So what's x and what's y at this point? Well, that's what I'm asking. What's x and y?
X is speed of boat in still water and Y is speed of current.
Okay, so x is the speed of the boat in still water, and y is the speed of the current. So with the current, you got x plus y, right? We got the speed in still water, and then you've got the bump that you get from the current. And then x minus y is against the current because you're fighting the current now, so you're slowing down.
What's like X to speed of the boat?
Yeah.
Y to speed of the current.
Yeah?
Oh, absolutely.
Good. Congratulations, you repeated back what I just said. I realized it took a while. You're processing it though, so that's good. All right. So, what equations are we going to get out of this?
X plus Y. 2x plus Y equals 24.
2x plus y?
With brackets.
What?
2 bracket X plus Y bracket equals 24.
Okay, so distance is speed times time, right? So 2 times x plus y equals 24. And what's the other equation? Right. Okay, what are we going to do with that? Divide by 2 and divide by 3. Sure, why not? 1, 2. Okay, let's take 1 divided by 2 gives me x plus y equals 12. And we'll take 2 divided by 3 gives me x minus y equals 8. What are we going to do with these two guys?
Add them.
Add them, right? Because we have a plus y and a minus y. So 2x equals 20, and x is 10. If x is 10, then y is 2. And, you know, you can solve that by inspection. Right? You look at it. Yeah, right? Okay. Let's go back here. Riverboat took 2 hours to travel down with the current. So with the current, it's going 12. And 24 kilometers at 12 kilometers per hour is 2 hours, yeah. And against the current, 24 kilometers at a speed of 8 gives you 3 hours, so that fits. Okay, and what do we determine the speed of the boat in still water and the speed of the current? So the speed of the boat. So all we're doing is basically parroting back the last sentence, right? Only we're making the last sentence as a statement instead of as a question. So the speed of the boat in still water is 10 kilometers per hour. And the speed of the current is 2 kilometers per hour. Okay? Questions? Last one. I'll give you a moment. You're still frantically copying it down.
Born on his head.
Surfing on the iPad there.
Oh, he has an iPad. Unfair.
Yes, if only the world were a fair place. Nicole. Another distance, speed, time problem, slightly different though, right? Nicole drove from Edmonton to Lethbridge in 5.5 hours. She drove part of the way at 100 kilometers an hour and the rest of the way at 80 kilometers an hour. So it's winter, you know, maybe there was good, good road conditions for one part of the journey, and then as she got into the other part of the journey, road conditions deteriorated, she slowed down, right? Being a sensible person. Determine how far Nicole drove at each speed. Okay, so again, distance, speed, time. I like tables, right? So we've got what? Part 1 and part 2. We got a distance. We got a speed. We got a time. Okay, how far did she travel at part 1? X. How far did she travel part 2? y. How fast was she going on part 1? How fast on part 2? How much time did she spend at part 1?
100 over x. 5
X divided by 100. You're just going to have a very tough time with distance, speed, time problems if you don't get the relationship between the three quantities down. Okay, so what can we say about x and y?
So this is
500, right? They're distances, right? Not times. Not listening. Don't speak out loud anymore. Just think it to yourself. What can we say about x over 100 plus y over 80? What? 5.5, right? Okay, how do you want to solve that?
substitution. Substitution. Right, the new equation.
Okay, solve it. There, you go solve. You can solve.
Oh,
You don't need me.
I solved it.
You might need me to get the to help you get the equations, but you don't need me to help you solve it now. So pick a method, solve it. I'm gonna wait a couple of minutes and then I'll pick a method and solve it. Well, I'm
Solved
waiting.
it, and then say terms, so screw it.
What day is today? 28th? 25th? What?
Oh, 26, 26.
26th. Today is the 26th. When you solve it, check with the neighbor. Well, first check the answer to see if it makes sense. Okay, does that work? Yeah.
Well, geez, I said that's 200. I said the wrong word.
What's the, let's say we write this as 11 over 2. It's the lowest common multiple of 180, probably 400, right? So what's that going to do? So, you know, so I'm going to start off by going 400 times 2. And then let's go 4 times 1. So y is 200. Okay, and then x is 300. All right, so she drove 300 kilometers at 100 kilometers per hour and 200 kilometers at 80 kilometers per hour. Right? Is that it? Done. Yes, done.